Ever pondered over the concept of stacked generalization in ensemble learning? It's a fascinating notion, isn't it? Well, today, we're going to delve into the whimsical world of this machine learning technique, making it as simple and digestible as possible. So what's this big, fancy term all about? Picture a team of experts, each with their unique skills and knowledge. They individually tackle a problem, then come together to combine their insights for the best possible solution. That's the magic of stacked generalization, or stacking, in a nutshell. In the realm of machine learning, this technique involves using multiple predictive models to generate predictions. These predictions are then inputted as features into a higher-level model, known as the meta model, to produce a final prediction. So, it's essentially models within a model. Quite a Russian doll situation, isn't it? Think of it this way. It's like running a relay race. Each predictive model is a runner, passing on their predictions to the next. The meta model is the final runner, taking all of the past batons, or in this case predictions, and sprinting towards the finish line to deliver the final result. Now, you might be wondering, why go through all this trouble? Why not just use one robust model? Well, the beauty of stacked generalization lies in its diversity. By integrating different models, it captures various patterns and relationships in the data that a single model might miss. It's like getting multiple perspectives on a complex issue, resulting in a more well-rounded solution. To summarize, stacked generalization is a sophisticated technique in ensemble learning, where multiple models are used to make predictions. These predictions are then used as features in a meta model to generate the final prediction. This method enhances accuracy and performance by capturing diverse patterns in the data. So it's not just about running the race, it's about passing the baton smoothly to get the best result. Remember, in the world of data science, diversity is strength, and stacked generalization is a testament to this principle, combining the strengths of different models to deliver superior predictions. So the next time you come across a complex problem, think of stacked generalization. It might just be the magical solution you're looking for.